Yeah, we are live now. Okay. Hello and very good evening to the webinar series organized by INDI Carbon Composites. ICC has put together a series of webinars for students and entrepreneurs by experts in the field to explore some of the core competencies using innovative tools and techniques. A warm welcome to the speaker, Mr. Jayesh Mahamuni, and all the participants who have gathered from different parts of India and different corners of the world. Your participation ignites and motivate us to push for better planning. And what binds us is a passion, a common passion to be effective entrepreneurs who constantly try to upgrade themselves. I thank the speaker, Mr. Jayesh Mahamuni, who at one call agreed for this webinar. Jayesh is a proud mechanical engineer and a composite enthusiast. According to him, he is the product of Formula Student competitions. He had participated in Formula Bharat as well as Formula Student Germany. He got a great opportunity to become the judge of cost and manufacture in Formula Bharat 2020. So the topic for today is effective use of composites in Formula students. Jesh, the platform is all yours.
Thank you so much, Akshay. Thank you so much for the introduction. Yeah, so talking about myself, my journey was just like you guys. So I was also a product of Formula Student team, and I worked in for 3 years in Formula Student team, and that experience was really great for me, and that actually changed my life. So I got a lot of experience from there. I got to learn a lot of things throughout the journey. So here I'll be sharing my experience, and I'll be just sharing with you what I know out of my experience. Okay, we all are students here, and this industry is really vast. So we'll try to keep it simple, and we'll share knowledge. We'll try to share knowledge with each other. Okay, so we'll just start. Let me share my screen. Yeah, so the topic today is the effective use of composites in Formula Student. Okay, so let us begin with this. Like, why composites? Okay, so there are a lot of materials available, but why to use composites, especially in Formula Student? So there are a few basic things that everyone will say. First of all, it gives better strength to weight ratio, and second is it's a race car, so it has to be lightweight. Then third thing is aesthetics, right? Because it looks really superb when you add up some composite materials. Okay, and sometimes because other teams are using it. Okay, I'm just kidding. This should not be the reason why should you be using composite materials. But yes, okay. So like how to compare the materials and how to choose a material. Okay, so this you can actually try on your own according to your own knowledge. Okay, so here are few materials which I have compared according to my knowledge. So according to like the criteria which I want to compare. So there is cost, availability, feasibility, and weight as well. So this is how you can actually rank materials, and as per the rank, you can actually decide then which is very suitable for you to use as per your purpose. Okay. Then these are few common famous fabrics that we generally talk about in composites. So yeah, carbon fiber, you all know that glass fiber, Kevlar, and something called as basalt fiber. Okay. Now, see, we'll just compare the properties of basalt, glass fiber, and carbon fiber. Okay, so you can see the tensile strength of basalt fiber is actually somewhere between the glass fiber and carbon fiber. Okay, in fact, all the properties for that matter, elastic modulus, elongation at break, maximum temperature at application. So, if you see compare according to the properties of the material, you will find that the basalt is something which is coming between glass fiber and carbon fiber. Okay, so actually I found this very interesting alternative for our use, that something that we can use actually into Formula Student. Okay, so let's talking more about basalt fiber. It bridges the performance gap between glass and carbon fiber. It's a great thermal and electric insulator. So carbon fiber conducts a little electricity, but it's a great insulator. Then strong, it's very strong and durable in harsh environments. and like performance wise it's quite impressive and advantageous at advantageous price. So even if you compare the cost, it comes between glass fiber and carbon fiber. Okay, so this can be a great alternative to use. Okay, now let us talk about carbon fiber, because that is the hot topic which is going on today, right? So everybody when is talking about carbon fiber, so why to use carbon fiber? Okay, you might be knowing these what we can say, these few words which are quite famous about carbon fiber, like whether it is a pitch type or pan type. It's a general purpose high performance activated carbon fiber like GP, HP, ACP, ACF, or it's a plain type, twill type, satin U, 1K, 3K, 6K, 12K, or 200 GSM, 400 GSM, etc. So there are a lot of terminologies into this. So let us understand what is the pitch type and pan type. This is from a book called Carbon Fiber Composites, and it's a wonderful book. You should go through it. So this no, a simple representation. You can see the pan polymerization goes through wet spinning, then stabilization, that is oxidizing process, then carbonization in inert atmosphere, graphitization, and then carbon fiber. Similarly, you can see for pitch type. Okay, so basically these are two processes through which carbon fiber is made. Okay, and then if you compare like the high performance fibers, those based on pitch can attain higher modulus than those based on pan type. Okay, because the pitch is more graphitizable than pan. So what is higher modulus is, higher modulus is basically lower elongation at break. Okay, and pan can attain higher tensile strength and greater elongation than those based on pitch, because first of all its shear is easier between the carbon layers in graphitized fiber. Second is pitch is more graphitizable than pan. Third is oriented graphitic structure causes the fibers to be more sensitive to surface defects and structural flaws. Okay, and then you can actually talk about the modulus. There is something called as high modulus, intermediate modulus, low modulus type, and high strength. So you can see carbon fibers with modulus greater than 300 GPa and strength to modulus ratio is less than 1%. That is segregated into high modulus type. Then intermediate modulus, you can see with modulus is up to 300 GPa and strength to modulus ratio is above 1 into 10 raised to minus 2. Okay, then low modulus type means its modulus is below 100 GPa and low strength. Okay, and then high strength is with the strength more than 3 GPa and strength to modulus ratio is between 1.5 to 2 into 10 raised to minus 2. So like talking about pan, pitch, high modulus, low modulus can be quite confusing and a bit complex, right? So let's talk about general terms which we can understand. So like we can actually that could be a deciding factor for us. Obviously these things are quite important to learn in terms of like, having knowledge and engineering, but let us come to the simplistic part of it. So what is plain type, twill type, and what is satin view, what is 1K, 3K, 6K, 12K, what is GSM, so 200 GSM, 400 GSM, etc. Okay, so let us come to this point. Like you can see this plane, you can see plane view, twill view, satin view. So in plane view, basically warp and weft are like one on one. Okay, one above, one below, one above, one below. This is the plane type. Well, now when it comes to twill view, what they have done is it goes from like two above, two below, and you can see a diagonal line. That diagonal line is called actually as twill. Okay, so you can see this is a 2 cross 2 12 view, and when it comes to satin view, it is similar to plane view, but just it is one above. So if suppose there is 4H satin view, so it is always one above 3 below. So 1 plus 3 is 4. That is the reason it is called as 4HS. Okay, similarly for 5HS, it is one above 4 below. For 8HS, it is one above 7 below. Okay, so this is a simple views. Okay, so basically when it comes to deciding which fabric you should use about carbon fiber, see you can do a simple like analogical experiment, or you can just think about it. Suppose there is one you can say one platform of 1 square meter maybe, and it has to you have to design it for to hold force of 350 newtons maybe. And then there is, suppose if you are using 3K 200 GSM fabric, okay, maybe plain type or 12 type, okay, and you have already used that previously, so you know how it performs, okay. Suppose that is giving you that is holding a force of maybe 100 newtons, okay. Just I'm just giving a random values, okay. So to hold a force of 350 newtons, you may require at least four layers of it, right? Now suppose if you are choosing another fabric, suppose 12K, okay, 12K fabric, then you might require that it's what you can say, its tolerance limit might be it might hold up to 400 newtons of force for the same area. Now you may require only one layer of it, okay. So if you compare, you can actually like calculate the what GSM it has, and according to GSM you can actually calculate for four layers how much weight it will gain, and for one layer how much weight it is going to give, okay. And then you can calculate how much epoxy or resin system that you will be applying to it, and you can compare the weight that you will be getting. So basically for same amount of force, like considering all the factor of safety and everything, understand that how much weight you want to put on your car, okay. So this is how simply you can actually decide which fabric to use, and decide what is required to you, okay. And check the these are few main topics. So check the availability of fabric, because you cannot choose anything which is not available on this planet, okay. So generally choose which is highly accessible, so that you can experiment more, and if anything goes wrong you can again make it available. Then cost is also a factor, because like lesser the availability, higher will be the cost, okay. And how much it is feasible for you to use. And then again, as we discussed about the weight part, okay. And don't select the fabric just because your seniors used it, okay. I'm not saying that you should not use the experience of your seniors, obviously you should use that, but this should not be the reason why you are using the fabric. So basically you should be knowing why you are using this fabric, okay, so that you can justify your methods. Now, yeah, coming to the further, but yes, let's talk about the resin systems. So these can be categorized into majorly three systems, like polyester based system. So it has quite less cost, it's faster curing, and but it has tendency to bond with water. So over the period, it might get damaged, or it can deteriorate. Okay. So like coming to the vinyl ester based resins, so it is basically a combination of epoxy and polyester base. Okay, so it is more tolerant to stretching, hence it absorbs a larger impact. It is more durable than polyester, and but it is not good for dissimilar structures. So basically, if you want to laminate Kevlar with carbon fiber, it might not go well. Okay, so avoid this. And then epoxy based, obviously, it is superior to both, and approximately three times stronger than vinyl ester resin, and it has high resistance to environmental degradation and higher impermeability to water. And obviously it's costly, okay, but it is highly advisable to use epoxy based resin systems, okay. Now, yeah, this is the important part, strength versus stiffness, okay. So like what do you think, what is more required in terms of like choosing fabric, or in terms of manufacturing? So you have to decide which component you are going to manufacture, and what are its requirements, okay. So analyze wisely whether you need strength or just stiffness is enough for that component, okay, because this is how you will be reducing your weight of the component, okay. Adding more CF layers to achieve stiffness will make the component over designed, and weight will increase like anything, and ultimately it will increase your cost as well, okay. So yeah, and then third one is mounting of the component, and its geometry can make the component stiffer. So you need not also worry about the fabric type that you are going to use. Now, to give an example, you must be knowing about side pods. Okay, so if you are designing a side pod, according to me, that should not go beyond 350 grams, and it is quite easily achievable. Okay, now suppose let us consider a cube. Okay, so if you consider a side pod, for like delete the entrance and exit of the side pod, and you can actually eliminate. Now there are four sides. Okay, now you can actually eliminate two sides round. So if you are like talking about the space frame chassis, you have a cockpit side, and maybe it is covered through side plates. And so one of the side of the side pod is closed by the side plate, so to the cockpit. And if you are designing an undertray, so its upper surface can be used as a lower surface of the side pod. So if you are actually eliminating four sides and you are just making two sides, okay. So you're by the design only, your weight, like you will be reducing weight a lot by a lot of margin. Second thing is, if you are mounting it sensibly, so you have L-shaped side pod. Okay, let us consider it as a L-shaped. And if you are mounting it on your both the open ends, okay, so all the degree of freedom is now is blocked. Okay, so it has no degree of freedom to flex or anything. Okay, and in this way you can actually make it quite stiff by geometry. And since you are using just two sides, your weight will reduce by a lot of margin. Okay, and you need not worry about flexing and everything. Okay, so this is how what you can do to reduce the weight. Now yeah, and this is the, yeah, so how to use sandwich panel. So what is exactly sandwich panel is? So sandwich panel is basically what we eat. Okay, so bread material, bread, it is same like that. So you are using carbon fiber. So use a core material between two layers of carbon fiber. It is simply called a sandwich panel. Okay, it helps to increase the stiffness, and it is much less weight addition. Okay, we'll come to this point again with proper examples. Okay, now study different core materials. There are lots of different core materials which you can actually use. You can use actually anything which is besides you. Okay, so you need not worry about searching going for costly materials or anything. You can actually experiment more on this part. It should make a good bond with resin, obviously. See, at the same time, it should not absorb much of the resin, because if your core material will absorb much of the resin, then it might actually increase your weight by a lot of margin. Okay, and physical testing of the panel is quite required to understand the permutations and combinations which you can play with. Okay, so like how much layers you should put above, put below, or how it should be. So you need to make a lot of panels with the core material, and you have to get it tested physically. Okay, and a perfect core material for your requirements can reduce the overall weight drastically. Okay, trust me on this. So this is how you can actually test your panels. This is a flexure test. It's a panel. And so let us take few examples. Okay, so this is the physical test for the software analysis. So we are considering two carbon fiber layers plus 3 mm of core plus one carbon fiber layer. This was particularly for one of the components. Okay, so if you see, at the load of 170 newtons, the displacement is approximately 2.442 mm. Okay, and yeah, its physical test results are almost similar. You can see the ultimate load is 170 newton, and displacement at ultimate load is 2.62. So it is quite comparable, and if you see the graph as well, it's quite comparable. So yeah, so you are actually validating your software analysis with the physical test, and you can actually go on with it. Okay. Now the second one I have tested is like 2 CF layers plus 1 mm core material plus 2 CF layers, and it is giving the displacement of 3.99 mm at 170 newton. Okay, and its results of physical testing are like this. So at the ultimate load of 170 newton, you are actually getting a displacement at ultimate load of 3.84 mm. Okay, the graph is not that matching, but results are quite comparable. So yes, and always trust on the physical test. Okay, it also depends how perfectly you are actually making the sample as well, because there are a lot of deformities, pinholes, so you might get variable results as well. So that is the reason why I told you make a lot of samples of similar fashion. Okay, so and get it tested. Now, what value addition will a core material can make? Okay, so let us consider the case one. So we have performed the analysis of 2 CF plus 1 mm core plus 2 CF. So if we remove the core material from that, so we finally end up with four layers of carbon fiber, right? So for the same displacement, when we were required to go till 170 newtons. If we go till 49 newtons, we are observing that much amount of displacement in this. So you can understand how stiffer it is going to, like, core material is making your component. Okay, and then this is a case too. So at 170 newton of force, we were getting a deflection of 2.442 mm. So if at all you are designing a component for that much amount of deflection, so if you are saying that up to 2.5 mm of deflection, it is quite okay for me, and you are designing for that. Now let us understand, if you remove the core material, you will be actually needing 8 number of CF layers, because if you are designing for 2.5 mm, you cannot stop at 2.9 mm. So deflection should be below that. Okay, so if you go up to 1.9 mm, you are actually adding 5 more carbon fiber layers. Now if you are adding 5 more carbon fiber layers, that means you are increasing your cost, increasing your weight. Again, it's not just in terms of carbon fiber, but you will be also adding respective amount of resin system as well, which will which will contribute a lot to the weight of the component. So that is the reason using a core material is quite important, and choosing a core material is also quite important. Okay, because it should make a proper bond with the carbon fiber as well, and the resin system. Okay, now yeah, coming to the manufacturing techniques, you must all be knowing the methods like hand layup, vacuum bagging, vacuum infusion. So vacuum bagging is just an advanced step of hand layup, where you are actually creating a bag, and you are using vacuum to put the pressure over the similar pressure all across the component, and you are you're taking excess resin out of the system. Okay, and in vacuum infusion, what you are doing is the pump is actually sucking the required amount of resin, and that is getting taking care of everything. Okay, and if at all you are using pre-pack or resin transfer molding, trust me, you have good sponsorship. Okay, so yeah, we'll not go into this detail of the manufacturing process. If you have any doubt, you can ask in the comment section. Okay, now yeah, one advice that I would like to give you is design to manufacture and not to impress, because I have seen this many times. Once we get a laptop and a CAD software, we can actually do anything which comes in our mind, but it is not quite feasible. Okay, so whatever you actually design, you should be able to implement that on your car, so it should be feasible for manufacturing. Okay, because whatever you design, if that is not coming on your car, that is of no use. Okay, so let's come to the manufacturing of bodyworks. You actually do not need heavy covering, not at all. Okay, if I give an example of nose cone, it should not weigh more than a kg. That too I am saying a maximum of a kilogram, considering it's quite a big nose cone. Okay, because it's just a covering, and if it is taking the shape of your chassis, so your chassis tubes are actually acting as a rib. So that itself is giving the component strength, required strength. Okay, so make it quite light, just like a paper, and it will serve the purpose. Okay, make it so light, and all you need in a bodywork is just a stiffness. And considering all the floorboards and all the bodyworks, I don't think it should weigh more than 5 kgs. You can do some reverse engineering as well, and check whether how much weight you can afford to put it on your car as per the performance of your car. Now coming to the manufacture of aerodynamic components, you cannot compromise on strength, and neither you can compromise on stiffness. Okay, everything is needed over here, because when we do CFD analysis of aerodynamic components, we consider all the parts to be infinitely stiff, right? We are not considering whether it is going to bend or not. So ideally you should be putting a component on car which is highly stiff. It should not bend at all. But obviously in the real case scenario, it is not possible, so we tend to reach to that stage. So any fluctuations are going to take you away from your ideal results. Make a note of this, and don't lose the balance between the stiffness, strength, and weight of the component. So in order to increase the strength or stiffness, you also need to check whether you are adding more amount of weight or not. Okay, which is under the limit. Okay, up to a certain limit, yes, obviously you can, but you need to check on that. Okay, and keep the target of manufacturing all the aerodynamic components. I'm just considering over here is front wing, rear wing, and under tray below 10 kg, which is quite possible along with all the mounting points. along all the mountings, and minimum the weight, the more the value it is going to add to your car. Okay, understand how much weight you can afford to put on your car to get the required downforce, and take the help of vehicle dynamics teammates, because its coordination between department will always help you. Okay, if the coordination is not that great, then it is not going to work. Okay, so take help from your teammates, vehicle dynamics, and understand, like, discuss and understand how much weight you are capable of putting in order to gain the experience. Because in order to increase the downforce, you might end up increasing more drag and putting more weight, which will actually degrade your performance. So take care of this as well. And what I would like to tell you is learn from the experiments. Okay, so do a lot of experiments. Everything, if everything is going right in your season, then trust me, you're not learning anything. Okay, experiment more till you make a new mistake. Wrong results are still results. Okay, so it shows that you are actually trying something new. So yes, always try to find a new mistake in your process, and make the experiment an experience. So you need to document everything whatever you are doing, and that is quite helpful for future references. Okay, and no need to worry if you cannot afford some costly material. You still have your brains, which is quite precious, and you can still make it really good. And learning is more important over here, because I have seen many teams using costly carbon fiber, but end up putting 20-25 kgs of weight over the car. It is always better to use some other material which is not that costly, but you use your engineering properly and make the weight, try to reduce the weight. So here you are actually the better engineer than someone who is using costly material but not actually using the resources properly. Okay, so don't worry about that. There are lots of materials which you can actually utilize and the experiment with. Okay, yeah, so these are few documented mistakes that we used to document. So I'm sharing this with you. So yeah, in the first year we had, like, you can read this. So during manufacturing, the mold wasn't proper, so it took us a lot of time to make it smooth by applying putty, sanding regularly. The seat mold itself took almost 1 month, but the final product was smooth, glossy sheet. So it was the worth the time. So why it is important to document all these mistakes is, see, if I give this to my, like, new teammates, if they read is like, they're understanding the fact that this might take a lot of time to get accurate results. Okay, and it is quite ultimately I am showing that after putting a lot of efforts, the results are really great. So you are actually making a mindset of your teammates that it is important to put that much amount of efforts in order to get a great product, and that is quite worth to learn these things. And then I also documented the second problem we faced was the under tray mold. It has a very small draft angle between the mid and side parts, so it had to cut in 3 parts, and it was then vacuum bagged individually and later put together by an adhesive. But it wasn't stiff when mounted because the mounts were designed such that it was good for a single unit. So we faced the problem of stiffness of the large under tray. And since we documented this, we actually bettered our performance in next competition. Then made it really great in the later competition as well. So this is quite important for you to document all of your mistakes. See, we have also written that the nose radius wasn't satisfied during FSG 17. So this was a quite simple mistake, but it should actually pinching you. It should pinch you so that you won't be making the same mistake again as well. Okay. Yeah. Now coming to the spirit of Formula student, see, it is all about. It is not just about a winning a competition or not, but you will here either win or you will learn. Okay. And do not copy any concept without understanding it. Keep it very simple. Understand the things. Yes, try to learn more from other teams which are doing really great, but don't just copy the concept. Okay, understand, learn from it, and then adding your own values to it, then use that concept. Okay, the formula student is not about scoring more points and winning. It is about nurturing the skills and make yourself a better engineer and implement everything you know. So this is the best platform to experiment everything, because no one is going to give a carbon fiber or any other fabric in your hand and try giving you a chance to experiment a lot. Okay, so this is the best platform that you can actually explore as an engineer. Implement everything you know, because knowing something and not doing is equivalent to not knowing. Okay, and ask why. Always ask why you want to do this, or why you are doing this. Okay, if you know why you are doing this, you will automatically find out some way to how to do it. So thank you so much for this uh, short introduction about the composites and how you can actually utilize this in your car. If at all any questions you have, I would like to ask you something. Maybe you can share your experience or something that you failed, maybe during your formula student experience, so that we can share it and we can discuss over it. Hello.
Where is it? Actually, you have those. This fan noise will come now. Wait, I'll go inside. Come inside only. Hold
Any questions,
jaldi.
guys? Any questions, guys? Hello. Okay, so one question is there is how do we decide how many layers and which layers to put in a component? Okay, so this comes with a lot of first of all, you should be having some experience, some kind of experience, plus whatever the physical testing that you do. Okay, you can actually use the software analysis, but don't rely on just on software analysis. Maybe you can analyze it on a software, makes panels, as we discussed in the previous slides. You can make the panels and test it on the software, and if you find it like feasible, then manufacture those components, those samples, get it tested physically, and then you can actually get an idea about how much strength it is going to give, because it is not feasible to make an actual component and then get it tested and so basically you cannot destroy that component, right? So yes, make a small components and understand how much like strength it can give to you, and then decide as per your previous experience. So if at like, because you are getting some values out of the physical test, right? So this is how you can decide how many layers that you should be using. And so what is the which layer to put in a component? I didn't get your question. Which layers to put in a component? Can we lay up multiple composites together? Okay, so yeah, you can use multiple components like multiple fabrics together, but like don't use the vinyl ester resin for that. That is not advisable to use. But I don't think there is any problem with epoxy resin. Anyway, it's like you are anyway using some kind of core material which is obviously not the similar to that of the fabric. So yes, you can use multiple fabrics as well, but that is not required as such, because if at all you are using carbon fiber, then like why to use something else to make a sandwich panel? Okay. How to ensure the quality while doing layup of complicated parts? Okay, so like quality in terms of what? Like, are you facing a problem with it is showing up like pinholes are coming up, or like what? Finally, you are the manufacturing tools. Yeah. Using composite materials, carbon fiber and glass fabric. Okay. Mr. Jitendra Singh. Your final weight is 2.3 kgs. How big is your component? If I can, yeah, length is 1.8 meter. Yeah, it's quite good. How to ensure the quality while doing the layup of complicated parts? You can use like if at all you are not like putting it in some kind of oven, or you are not using heat, you are not heating it up, you can simply use kind of heat gun, which before applying all the all the fabrics or all the consumables before vacuum bagging, you can just apply that, so that any pinholes or any bubbles, air bubbles which are into the components, which will get released. So ultimately you will get a good good kind of finish for the part. Any more questions?
Participants, you can unmute yourself and ask questions.
Yeah, sure. Can you just let me know which complicated parts you're talking about? Jill shape.
Parts that are vertical or have T-shaped bends or something like that.
Sorry, I could not hear you.
Parts that are vertical at 90 degrees or have a T-shaped bend or something like that.
Okay, so you can actually make like, are you talking about any kind of like side pod maybe, which is about 90 degree, like that?
Yeah, something like that.
So you can, so this comes like you can actually play smart with the mold making. So you make a mold which can give you a kind of V shape. So it will be easier to for the laying of the like fabric and do the layer. So you don't make a mold like just extrude that and it will give you a normal L shape. So if you place it like this, you can place it like this or like this. So make a mold such that you can put the component like this. Okay, so it will give you a V shape so that you can easily, so the resin will not drip off much, so it will be easier for the layer purpose. I hope I answered your question.
Yes, thank you.
Hello, Jayesh.
Yeah.
First of all, thank you for your presentation. I just have one curious question. I never work in this carbon fiber based composite.
Okay.
But I would like to ask you one question. For the recent days, particularly in Europe, you might be heard about a material graphene and graphene related composite. So do you see some chances of addition of graphene in this kind of fiber composites, and you see some synergic effect, particularly for the industry? Research-wise, there are some reports, but I would like to understand something if you are aware of any products at this moment in the market.
To be very honest, I'm not heard much about the graphene addition of it. So yeah, this will be a like another altogether another discussion to for the research purpose. So yeah, but if you can like mail this question to me, I can get back to you at any time. So
Sure.
I'll need to do the research over this. Okay.
Okay.
Just mail this to maybe Indica Composites or me. Okay.
Sure. Thank you.
We'll get back to you.
That's
Any more questions, participants?
I have a question.
Yeah, go on.
Yeah, which material should I use as a mold for monocoque chassis?
Monocoque chassis, see, it depends. You can actually use multiple molds. So one you can use is MDF, which I would suggest you to use because you will not be continuing your part as it is like. So you need to change your monocoque as per like the design of monocoque every year. Okay, every year or two. So obviously you need not make a very like a metal mold. If you can, then obviously who won't say that you should not be using metal mold. But yes, you can use MDF mold, which will work really super. Okay, and yeah, other than that will actually serve your the purpose for a monocoque, which will give you.
Which one would be the easiest to manufacture with? Like
Sorry.
which mold would be the easiest to manufacture?
See, for the monocoque, once your design is finalized, obviously you will need to do the CNC manufacturing of mold. So yeah, I don't find any easy or difficult part to do it. It is better to have a CNC machined MDF, so that it will give you a precise and very quite accurate mold, which you can
Okay,
work
so
on.
it would result in better surface finish,
Yeah,
basically.
surfacing is something. Yeah, obviously, with the CNC machining, you can attain a really great surface finish, but ultimately, you will also do some work on that as well in order to get a superior finish. And it is always better to it is always advisable to work on your mold rather than working on your component after after the production. So how, if you are making your mold like a mirror, your component need not do even a post processing for that matter. And talking about the formula student, there is no need as such of post processing and making it quite shiny. You need not put even that amount of weight on your car as well. So rather work on the mold to make it like mirror finish, to gain the mirror finish, and rather than working on the product after the production.
All right, thanks a lot.
Yeah.
A mirror finish mold helps you to demold your parts very easily. That's very important.
Yeah.
Or else a rough surface will create a lot of problem while demolding. So take care about that.
Yeah, obviously. And also, yeah, and obviously a rough mold, yeah, the demolding problem is a big problem. But also you need to have your product quite accurate and good looking. So obviously it is better to have a good surface finish on the mold itself.
Jayesh, there's a question in the chat box. Check it out.
Yeah, for VRTM, how to decide the number of inlets and their position. So according to me, it should be decided as per the design of your component, and basically it should flow and it should reach to each and every corner of your component. So I'm not the expert on this to comment on VRTM, to be very honest, but this is how it should be. So it might vary according to your product component to component.
It all depends on the size of your component.
Yeah, obviously. Size
And
yeah, sorry.
yeah, it all depends on the size of your component and the number of inlets. Sometimes even one inlet is enough for it,
Exactly.
because the resin shouldn't move very quickly. Sometimes it leaves dry spots.
Exactly.
So take care about that. You have to if you're doing VRTM, there's a flow mesh that has to be laid properly. Even if you leave it at a corner, that corner will be your dry spot. So take care about that. Any more questions? Okay, I guess we should end the session.
Yep.
So I'll call Miss Aditi Shah to give out the thank you note.
Good evening, everyone. On behalf of INDI Carbon Composites, I would like to thank Mr. Jayesh for volunteering his time and providing us with such an informative, engaging, and interactive session on the topic of effective use of composites in Formula Student. Mr. Jayesh has explained the topic in a very unique and easy to understand manner, which can be of immense help to all students and emerging entrepreneurs, as well as people looking for development in the topic of composites. The examples explained by you, as well as the concepts, were extremely easy to understand and relevant for understanding the topic. I would also want to appreciate the efforts of Mr. Nadeem Khan for providing the necessary technical support to INDI Carbon Composites. Many thanks to the host and convener, Mr. Akshay Dhotre, for organizing today's session and the upcoming series of knowledgeable videos on the topic of business, technology, and composites. This series of videos will enable us to gain immense knowledge in various areas, so do stick with us during the workshops. We at Indian Carbon Composites appreciate the feedback obtained from all the participants and look forward to such enthusiasm from our participants in the future as well. Once again, a huge thanks to everyone. Have a great evening and do share the videos to share your knowledge of composites with others in the same field. Thank you.
Yeah, thank you so much, Akshay. Thank you so much, Indie Carbon Composites, for the wonderful opportunity. Okay.
Welcome.
Yeah,
Thank you, Jayesh.
yeah.